Okay, so as a simple thing like to talk about the number of devices introduced. So V bonds we are going to group them with active, active, active. All the V bonds will be into active state, and all the V smarts will be into active state. They do have OMP adjacency with each other within the group. V manage will be kept in the cluster. Three V managers will be into active role, and three V managers will be into standby role. So more number of V bonds, more number of vSmart, and then more number of vManagers to retain the network with high availability and the horizontal scaling implementation with SD-WANs. So controller scale, we manage validated scale up to 2000 devices per single instance. Maximum production deployment, 6 we manage instances in a cluster, 3 plus 3 active and then standby. vSmart, 5,400 connections per single vSmart, and maximum production deployment 20 vSmart. Okay, so again, as a standard information, like they are limited up to 20, but with enhanced licenses and then enhanced permissions from Cisco, we can operate more into it. And vBonds, again, validated scale 1,500 connections per single vBond, and maximum production deployment 6 vBonds. Okay, so at this moment, we take a standard information plus based on the Cisco's privileges, we can increase more number of devices, more number of vSmart, and then more number of vBonds into the hierarchies. So deploying the controllers, obtain documentation and then software from Cisco softwares. We can download the virtual image. So we download the virtual image for vBond. We download the virtual image for vSmart and then vManage. We deploy we import the OV and we deploy the virtual machine, and at the time of virtual machine deployment, we will initialize them. IP, system, site ID, organization, vBond, and then NTP, and will be ready to communicate with other components. If using enterprise CA server, the enterprise root CA chain, because certificate will play a main and a major role. As I told you, like unique identity, authentication, everything is controlled through the digital certificate. They must have it. So since the controllers are virtual machines, they don't have any inbuilt certificate, and they don't have any inbuilt root certificate database updated. So they do have inbuilt basic certificate and from the software some root certificate, but they are not basically used for identity. So before the controllers are initialized, so three things we must make sure. The first thing is always VPN 0 with control interface IP for the reachability. Then second thing is system configuration. Based on the system configuration, system IP, site ID, vBond informations are mandatory to be present. And the third thing, this device to be authenticated by others and also to authenticate others, it is required with a device certificate. If virtual machine, obtain the certificate manually, install it, or else log in into the console or log in into the VM and in the CLI and obtain the certificate and then install it. At any mechanism, whether we are going to do it in the online process or we do it locally, we we just get a certificate for the devices we install locally, and we update the root certificate to trust other devices. So VPN 0, system and device, both device certificate and then root certificates are important, so that using these three information, this is ready to talk with other component. So system IP, unique IP address, it's a 32-bit IPv4 address. Logically, VPN 0 loopback interface referred to as system. A logical interface is created using the system IP address, organization name, and unique site ID for an like you can say like logical representation. Identifies logical locations of individual nodes. So deploying vManage on VMware ESXi. So a vManage. to support up to 250. So number of virtual CPUs, RAM, and OS volume, database volume, plus number of VNICs we try to initialize this. Up to 1000 devices, or more than that, up to 2000 devices. So 32 virtual CPUs, 64 GB RAM, and then 16 GB of OS, and database volume plus number of interfaces to R3 to be utilized. Some basic picture. We know that deploying vmanage OVA on the VMware ESXi, we deploy the VM, that OVA will ask for the provisioning, and then once the virtual machine associated properties are defined, we can say like single interface. By default, the virtual machine will be presented with one interface only for VPN 0, and we will provision additional interfaces. So this VM settings add additional interface for convenient OOB management. So we can take second interface management access. So once the virtual machine is initialized, okay, we'll load the OS. This is like Viptela OS. Remember, controllers are with Viptela OS. So Viptela specific commands, we try to provision it. So Viptela commands are similar to Cisco, but not exactly like Cisco. Okay, so Viptela commands and Cisco boxes, C edges will follow Cisco commands like a standard iOS or standard iOS XU SD-WAN version commands will be applied. So Cisco routers configurations will be the traditional way, but Viptela commands will be something different. Just to give an example, VPN 512 interface ETH0 is part of VPN 512, and VPN 512 is the default route. Even DNS could be configured in it way, and interface, sub interface mode, IP configuration, and then gateway, no shutdown, exit. Again, in the privileged mode, VPN 0, install the default route and then DNS. That means um, inside the VPN, common configuration, and inside the VPN interface, and then interface specific configurations. The system and then system details could be configured, like system and then sub configuration mode of it. So this is like system object and then associated configuration. This is called as VPN 512 object, VPN 0 object. In it, interface object is mapped, interface object is mapped. This is a way like configurations could be initialized. So the basic picture, the first login with the vmanage. Vmanage will open these settings like administration settings, the configurations what we have done it in CLI. If I want to modify to the GUI, we can do organization name changes, the configured vbound IP address to be modified, or anything like to change it in the GUI, we can do. So deploying vbound, the same behavior, up to 50 devices and up to 250, up to 1000, and then 1000, 1000 plus. So number of virtual CPUs and RAM operating system and throughput provided by these boxes and number of VNICs required to this. So two VNICs more than enough, one for VPN 0 and one for 512. Since like they are not going to handle much traffic, they don't need more number of virtual CPUs. So just only like connections are permitted, and UDP based validation takes place here. When RAM also 4 GB, so two CPUs and then 4 GB with the minimum storage, like it works, because vbound stores limited information, like only the whitelisted entry, like whitelisted controllers, whitelisted vanages, chassis ID, and then serial number. Apart from that, it's not going to store any data. So vbound, same configuration, nothing new we try to do. Under the system, host name, system IP, site ID, organization name, vbound IP address, and then local, commit the configuration change. So commit is important. Whether we go with iOS XCS D-WAN or Viptela OS, commit is to save the configuration. So vbound interface. The one thing what we need to notice here is um, vbound is configured from the image of that is virtual image of VH. That means VH can be assigned with additional role of vbound. So vbound interface will have ETH 0 and gig 0 by 0 specification. Since like gigabit Ethernet or gig 0 by 0, 0 by 1, 0 by 2. This VH interfaces will talk to the transport connecting to transport 1, transport 2, transport 3, and these interfaces will be called into VPN 0. ETH0 is dedicatedly for VPN 512. With vmanage and then vbond, sorry, with vmanage and then vsmart, we don't see gig 0 by 0. That's LAN interface because they're all dedicated images. We could find ETH0 and then ETH1. So the point what I mean to say, for vmanage and vsmart, we do see ETH0 and ETH1 interface. ETH1 or ETH0 will go into 0 or 512 VPN. So vbound and then vanages will have a similar design. Vanages normally like depends on the transport, all the interfaces will be called into VPN 0, but vbound ETH0 will go into 512 and then gigabit Ethernet 0 by 0 will go into VPN 0. So we need to look at, because why I'm trying to insist here, like configurations, what we try to make, what interface is VPN 0 and what interface is VPN 512, just to have a default information on top of that, this classifications. Okay, so since it's a configuration related to VPN, for example, VPN 0 on similar to the Vanages. So these commands will come in. So nothing to worry about that. I will explain this command. So VPN 0 interface is called, and this is enabled as a tunnel interface, and this is permitted with all the protocol like net config session, NTP, the routing protocol, and other stuff. So tunnel interface, tunnel IP, tunnel encapsulation, tunnel color, all things we try to do under the VPN 0 port. So VPN 0 interface is pre-configured for WAN. Tunnel interface configuration settings lock down the interface and also prevent incoming net config session. When vbound is integrated, we will re-establish these sessions. Recommendation: disable the tunnel interface while performing controller. After that, we will enable it. It's a limitation because we are promoting Vanages to be into the vmanage role. So tunneling, tunnel establishment, IPsec, VPN tunnel establishment logics we disable. By disabling them, we tell vbound to talk with others to form the connections and then tunnels and everything. Then we will enable it. Okay, it's a standard procedure. Nothing to worry about this. So configuring the vbound IP, VPN 512, ETH0 IP, and VPN 0, gigabit Ethernet gig 0 by 0 IP mask, and then respective gateways, plus the system configurations. vSmart is also in the same way. Number of virtual CPUs, RAM, and OS, number of interfaces to be utilized. And also we could find ETH0 and then ETH1 interface. So ETH0 and into default VPN, ETH1 into not set. So ETH1 we will provision into VPN 512, which is management. Okay, so ETH0 to VNIC2. So we will try to map it. So while we are trying to map it, and this is like for VPN 0 transport control, or it's for the OOPs. VPN 512, same configurations we do. VPN 0, same configuration plus system configurations we do. So the idea is the same. We deploy the VM, and the VMs are initialized with the two NIC interfaces. Each NIC will be with VPN 0 and VPN 512 configuration and unique configuration under the system. So far, as an picture, you can see it here: VM1, VM2, VM3. So first interfaces are on VPN 512 for management access. Second interface on VPN 0 WAN subnet, and this VPN 0 will be connected to talk to the external network through the provider path. So virtual machines running on KVM, VMware ESXi, AWS, Azure, separate interface for control management, separate VPNs for control, and then zone-based security is introduced. Okay, so this is the first thing what we need to understand about deployment. So we need the basic configurations for VPN 0, VPN 512, and then system. Then the IPs will become reachable with each other. Now they are reachable. they are connected into the network. They are uniquely identified using system information. So how do we integrate these components to work together? So this integration process could be defined in this way. So we manage after the initialization, it has no information about vSmart and then vBond. That means vManage has no visibility to other controllers. And this is not available the information to other WAN edges. Now, first we integrate the controllers, then we will talk about the WAN edges. So in the vManage, we have a whitelisting steps. In whitelisting steps, we need to say add the vBond manually and we add the vSmart controller manually. It's nothing but we try to give in vManage the IP address of the vBond and we give the username of the vBond and then we try to provide the password for this. So username and then password to log in into the vBond. In vManage, we try to add it. Similarly, vSmart1 IP address to connect and then username to log in and also to associate and the associated password. So in vManage, we are manually whitelisting each controller by providing the controller IP address and associated login credentials. So vManage is initialized and then vSmart is initialized, vBond is initialized. I gave VPN 0, VPN 512 system settings, VPN 0, VPN 512 system settings, VPN 0, VPN 512, and then 5 system settings. Now, vManage knows there is a vSmart in the network, and vManage knows there is a vBond in the network. But the thing is, this is a virtual machine, this is a virtual machine, and this is a virtual machine. These boxes are not having any device certificate from where we are going to take the certificate. Before obtaining the certificate, what is the public key and then private key used, and what is the public key to be exported or to be connected under the device certificate? Now we will generate a CSR. So remember,
One
in
question.
case of sure, go ahead. Yeah, yeah.
Sorry to interrupt you in between. Yeah, actually, you said that we need to provide this IP address in order to do the whitelisting. Now, coming to this credential, user ID and password. So, what would be the user ID password? Is it that admin credential? Because so far we have not created or provided any additional user ID password, right?
Yeah,
During
that's
the
right.
initial
So
configuration.
while we're initializing the vBond virtual machine, it will ask you the admin username and associated local credential. vSmart will have the admin username, local credential, and this admin and local credential we need to provide in this place.
Okay, okay. Please go ahead.
Yeah. Okay. So since these boxes are virtual machines, no inbuilt certificate. Now as a certificate hierarchy. It's not only related with SD-WAN, as a certificate hierarchy, if a server wants to communicate other devices for certificates, now it has to generate the keypads. It's supposed to generate the public key and then it's supposed to generate its associated private key. So both public and then private key combinations. Now this public key is mapped along with some certificate information, for example subject informations. We try to provide the email address, organization name, and whatever the additional informations we try to provide, we will map it. So this additional information plus the public key, so both will be sent into CSR, certificate signing request, and this certificate signing request will be sent to the certificate authority and then CA will sign the CSR into the certificate and then certificate will be returned and certificate will be installed into these devices. Same procedure, vBond needs a certificate. So vBond has to generate public key, private key, and this public key should be sent into CSR and CSR should be copied into or sent into CAs. vSmart, public key plus additional information should be sent to the CA and then to get a certificate. We manage public key, private key, and to send its public key plus additional information to CA to obtain the certificate and install it. Now, there are two options or two ways we can do it. The first way, we locally log in into vBond. Okay, since vBond is available with IP and as a network reachability, we just tell that, okay, give a manual command to create public key and then private key, and then copy this information with the system specific information or additional information, then generate the CSR. So CSR will be sent here, and then send the CSR to the CA, obtain the CSR based certificate, and then install it locally. So each machine can generate the CSR locally, and sending the CSR information to the CA, obtain the certificate, install the certificate locally. Or else this can be automated through vManage. So what we can do, okay, we choose, okay, we log in into vManage. Okay, we choose a vBond, and for the vBond, okay, we just trigger copy, I mean generate the CSR, and whatever the CSR generated, we just download from vManage. Through vManage we can send it to CA, download the certificate and install for the vBond. That means CSRs are still generated for the vBond, and then vBond through vManage, it collects the CSR from them, forwards the certificate CSR to CA, downloads the certificate and installs back into vBond, and then install back into vSmart as a proxying device. So through vManage, we can automate the certificate installation procedure for the controllers, or like vBond directly talks to the CA to get a certificate. vSmart directly talks to the CA to get the certificate. vManage directly to talks with the CA to get a certificate. So we generate the CSR, and we sign the CSR, and we download the certificate after signing from the CA, and we try to install it. So once the devices are with system configuration VPN 0 plus the installed device certificate, and this is ready to establish control connections with other devices. Optionally, we can install, or like additionally, we need to install the license file towards to it. So integrating controllers, vManage should be whitelisted with the participating controllers, and these controllers are required with these certificate, whether they are going to obtain that manually, or I mean locally, or they are going to take it from the vManage. So this is again, it depends on our design. We can choose, like through vManage we will install the certificate for them, or locally.
Parthiban, I have just one question. I mean, you said that there are two steps in order to generate device certificate. One it's through manually, and then one it's through vManage, right?
Yep.
So while doing manually, we need to manually log in into the device. Then we need to create the public private key. I mean, login into the device means login into the controllers, right? So login
Correct.
into the controllers, create the public private key, and then on step 2 we need to send the public key plus the organization name to certificate authority body, that is the
Correct.
I mean, certificate signing request we need to send to CA, right?
Correct.
And then
Hmm.
in return the CA will send the device certificate to the controllers, right? And then we need
Correct.
to manually install that device certificate into the controller, right? This is one method. And the
Correct.
second
Hmm.
method is that uh, instead of doing the things on CLI, we can go into the vManage, and through vManage, we can generate, I mean, certificate signing request
No, no,
on
no.
behalf of those controllers.
No, 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 no. One small point I want to clarify it here.
Hmm.
CSR still generated by vBond or vSmart. So
Okay.
vMany will instruct vBond to
Uh,
generate the local public key, private key, and then local CSR. vManage will copy the CSR.
hmm.
vManage will send the CSR to CA, obtain the certificate from the CA, and installs the certificate associated to the CA back to the vBond or vSmart. So CSR for vBond, CSR for vSmart, vManage don't generate, and this is not possible also, and it is not practically secured. So vBond generates its local CSR, vSmart generates its local CSR. The difference here, whether vBond sends its local CSR directly to CA, or vBond sends the CSR to vManage. Through vManage, it is going to get a certificate from the CA. That's the second option.
Okay, and in return, vManage will retrieve the device certificate of those vBond and vSmart, and then again it will forward back to those controllers.
Yes, okay. It will take the certificate from the CA, it installs the certificate back into vbond 1, vbond 2, vsmart 1, vsmart 2 to the specific locations.
Okay, so vmanage will install this into vbond and vsmart. There is no
Yeah,
manual
basically
intervention needed.
it's a kind of proxying device. When we introduce proxy servers, so client and end servers are going to talk. So client connections are intercepted by proxy, and proxy initialize new connection, gets the information, and then forwards it back to the client. The same procedure, vbound required with the certificate. It generates a CSR, passes the CSR to vmanage. Vmanage passes to CA, and then they obtain the vmanage obtain the certificate from CA, and in gives back to the vbond, and vbond installs it locally. This is how it takes place in the centralized second procedure.
Okay, and now if say the CA is different for vmanage and vsmart, so in that case you said like we need to install the root certificate into the device as well.
Right. Yes.
Okay.
We have to update that.
Uh,
Yes, I can show you this as well. In the vmanage, okay, so we do have a configuration. In the configuration, we do have whitelisting. In whitelisting, we could find the first option is for WAN edges. So WAN edges whitelisting, and then controllers whitelisting. So add controller option will come. In add controller, we give the IP address for vbond or vsmart. We give the username and then password, then generate CSR. If this option is selected, and this device will be generating its own CSR, and this CSR will be collected by vbond. So vsmart is also added in the same procedure. And then on the GUI, we can find vmanage one, vbond is added, and then one vsmart is added. Even in the CLI show control connections, it shares like the status between this component. So show control connection history. Is there any connection TCP related or UDP related comes in? We can track it. But I can give you the details in detail. But you can see show control connections history, and then show control connections also in the GUI. We can be able to validate it. Okay. So each device is required with its unique device certificate, and this device certificate can be locally installed or it can be installed through vmanage, and vmanage can automate the root certificate installation process for other component. So whitelisting of controllers. When it comes to the vanages, these are default behavior. It has got VPN 0 for transport communication. Multiple transports can be connected on VPN 0. One interface will be for VPN 512, VPN 512 OOB communication. Apart from that, service VPN 1 to 511. So VPNs are isolated, and each VPN has its own forwarding table. Reachability within VPN is automatically advertised by OMP. So routes will go from VPN, service VPN into OMP, and vice versa.